Hello everyone, this is Monte from Python Ninja YouTube channel, and in this tutorial we will learn together how can we build a Python function that simulates random walk and Monte Carlo estimator. A random walk is a direction that is chosen directly each step along the way. Suppose your way starts from this origin point. So the random walk is the direction that is taken along way each step along way. So you can choose to start from this origin and you go left, you go right, you go up, you go down, and any direction that is it's choosing, okay, randomly to reach any target or any destination is considered random walk. Okay. Suppose you live in a city where streets are arranged perfectly in equally separated grid, like this. This is only for illustration, okay? Where when you go leave home and decided to walk, you go straight, reaching the any intersection to change the direction. Meaning that if you live here and this, like the whole zone of your city, like designed perfectly, okay, in a square grid, so you can choose to go to this destination, then you will walk. There is a chance to take this direction or this direction or any direction to reach to this point. You can choose to walk, for example, 1, 2, 3, 4, 5, 6 along x-axis, and you choose 1, 2, 3, 4, 5 and 5 along y-axis. So you need like a double of 6 from x and 5 from y to reach to this destination if you choose to move as what I described to you. And the total sum of these two numerical value give you the total length, okay, that measure the destination or the distance between your house and the destination you are going to visit. Now, in this grid that we will use, or just to visualize how the random walk use, we have 4 directions. Okay, so the code that we will write is restricted to 4 directions. We have east, west, north, south, meaning that if I go one step to x, I choose east, and I go one step to minus x, I choose if I go to west, I will decrease x by 1. If I go to the north, which is up, I increase y by 1. If I go down to the south, I decrease y by 1. So there are 4 directions, which are east, west, north, south, and your starting points lie in the middle like this. This is all in the origin, okay, of your house, where x is equal 0 and y equals 0. Here, x 0 and y 0. But if I move here, then x1 and y 0. If I move here, I count to 3x and 0y. But if I move here, I count 3x, okay, and I have 2y's, okay? So this is the grid or the way that we simulate the random walk, okay? So the random walk is nothing but like intuition or a methodology where 2 parameters x and y can be changed, okay, based on the grid and equally distributed grid, okay? So when you finish your walk, okay, meaning that it stopped at a location x, or let us to say location, and just to distinguish between the x that is used in our metric, you count the distances, okay, based on the number of spaces, okay, meaning that if you decide to stop here and here is L, you count 1, 2, 3, 4, 5 in this direction, x equal 5, and you count 1, 2, 3, 4, 5, 6 equal, for example, 5 or 6 to the y direction. You can choose to go from this direction to this point. You can choose to go from down reaching up. So this is random walk, but the steps to the left, to the right, to the top, to the down are equally distributed, meaning that if you go to the east, you increase x by 1. If you go to the west, you decrease x by 1, and vice versa for y, and that is associated to the north, and minus y that is associated to the south. Okay, So the program that we want to write contain like two steps. The first one is to write a function that will simulate what I was describing. So we will need a function that will change the value of x and y based on random movement. Okay. Now this random movement is based on x to the four directions, which are east, west, north, south. Then we want to estimate what is the longest random walk you can take, so that on average you will end up 4 blocks, or if you are from the home. So at the next stage, we will write a function that will also use to estimate the longest random walk. So suppose I walk randomly from down to the west to the north, then I have to end up 4 blocks from home. For example, I count 1, 2, 3, 4. Like if I stop here, I count 1, 2 from y, from to the south. I count 1, 2. Then I count to the x to the west. I count 1, 2. Then there is a chance to stay here, or there is a chance to stay here, or to stay here, or to stay here, or any place. So we take longest round, but I will stop at a location where when I count it to when I count these spaces, I have to have a result of 4, even in this direction, or in this direction, or to the top, or to the down, or here, or any place. We will learn together how can we will end up. So this is nothing but an example. You can change it like to 6 to 10, but by this example, we suppose that if you end 4 blocks, from your home, or 4 steps, then no need to take the public transport, or the probability to take a public transport is like equal to 50 or less, 50% or less. So if you reach the probability of 50 or less, then you code this equation or this function in our way. The first thing is to simulate the random walk. So to design a function of random walk, we work with random. So we need a random module, and we want to define our random walk function, and this function will take these steps. For example, if you decide, I would like us to say that number of steps, if you decide to move 10 steps, so we will give to this function 10 steps. 10 steps means that if you move like 10 over there, 10 over there, 10 down, 10 up, or you can take like 5 here and 5 top, or any combination of these 10 steps. Now what we will do, we will define x and y as what we described in this algorithm, that we will have x and y both in a form of table. So I use x and y equal to 0 and comma 0, because we initialize this x and y by 0 and 0, and I will loop for I in range to the number of steps. What I will have to do, I will say the steps equal random. We learned together before about the random choice. We want to choose from this list, from east, or from west, or from north, or from south. Then I want to go through if condition. If step equal, for example, s. What I have to do, if the steps are equal to the s, then I sample s step. S step will increase x by 1, west decrease x by 1, north increase y by 1, and south decrease y by 1. So mean that yx plus equal 1. If steps equal west, they are capital letter. West meaning that x minus equal 1, because I move to the direction of minus x. Lf steps equal north, then I move to y plus equal 1, I increase y by 1. Else the last condition, instead of saying steps equal south, I just say else y minus equal 1 because this is the last condition. So I use east, west, north. Okay, east, west, north. The remainder is south. So I use else. And finally, I go back and I will return x and y. And remember, x and y, this function will return x and y in a form of tuple. So if you use like this is okay. If you don't use like this, any form like this means that we return a tuple. Okay? This is the simplest form of random walk function that is used in mathematics. Okay? So now suppose that I want to move 10 steps. So I want to move any random 10 steps from east, west, north, south, and I want to make a repetition or a trial of 30 times. So I move a random walk of 10 steps, okay, but I want to repeat this 10 times to take all directions, okay. So because I want to repeat this experiment, okay, 30 times or 30 trials, so I take for let us to say t in range from a trial, okay, 30. I repeat the function calling, which is this one of 10 steps. So I move 10 steps, but 30 random times, okay. This is the exact interpretation. Okay, so I move this. So the walk is nothing but the invoking of the function, okay. Or recalling the function, and we said that we want to move 10 steps. So I count 10 steps to x, 10 steps to y, 10 steps to any of this direction. Okay, so I will bring now, okay, for trial, okay, so we repeat the experiment for the trial, okay, and I want to take t, okay, then I want to say the distance because we say that if I move like 5 from x, okay, and 6 from y, then I just add 5x and 6y to show you the exact length of the distance. So I just take the absolute value. If I move like in this direction or in this direction, I will have minus y and minus x. But we need actual distance, so we neglect y. So the signal, because the signal is nothing but the direction here. So I want to take the absolute value of the sorry, this should be walk. Sorry, this walk like this, and the absolute value of walk, because it's a bubble. So I want to add the 0 index of the walk, okay, plus the absolute value of the walk, okay, of index 1, which means this means we add x and this means we add y. Let us execute the code, and you can see here we repeat the experiment 30 times. We repeat the trial 30 trials, or we took 30 trials by repeating function calling for 10 steps 30 times. At the first trial, we end up 6 steps, okay. For example, it could be 3 from x and 3 from y. It could be 6 from x, okay. It could be 6 from x positive or 6 from x negative. I don't know, but this is based on the random function that sample east, west, north, south, which taken from random.choice line, which is this one. And you can see at the second trial, if we repeat the experiment, or if we repeat function calling another time for 10 steps, we will have 2, okay, until reaching the 30 trial. You can repeat, for example, till 1,000 trial, or however, you can just repeat for 1, or you can take only 1. You can call this 14 times, but we want to test the randomness in a better way. So whenever we have the function that consider sampling or choice randomly, we repeat the experiment many times just to see where our confidence, or where the confidence interval. We also, this is the basic form of the function. We can optimize the function in more efficient way. For example, instead of looping taking these if conditions, we can say, for example, I can take bubble of the distance of x and the distance of y, or you can just remove the bubble, so you can take the distance of x and distance of y, which are equal to the random dot choice, okay, dot choice, okay, and I want to select from a list of bubbles. In the first bubble, I move to the east, and in the east I move 1 to x and 0 to y. Then I move to the west meaning that I will decrease it. I have the first one to the right, which measure the east. The west will be -1 and 0, because we consider the other direction of x. Then I consider the north. The north will be 0 with 1 and 1, because we have 0x and 1y, and we will consider south, which will be 0x and -1y, because we go to the other direction. And if I, for example, I randomly select 1 and 0, okay, then 1 will go to x, okay, and 0 will go to y, okay. Then in the next stage, suppose I choose this one, okay, then x will go to 0, and -1 will go to distance x to the west, and 0 will go to y, and each time this function will return only one tuple to me each time, and it will assign this to the dx and dy, and I can take dx and dy to update x and y like this. So I have y plus, okay, equal dx, and I have, sorry, why did this distance? Okay, then I can also consider y plus equal dy. So if I sample this one, then x will be assigned to 1, and it will be increased by 1 here, and y, nothing will affect y. But if I sample this, then -1 will be assigned to x here, and x will be updated by -1, x plus -1, meaning that we decrease x by 1, okay? And this is more simplest than the first one, and we reduce some lines of code, and that's more professional. But we can repeat, for example, the execution, then we will have a similar result, but because we use random function each time, we will have different implementation or different results. For this trial, we move 10 steps here, okay, 10 steps, and we count it. So I move 10 steps. Suppose in the first time I move to x, I increase x by 1, then suddenly I move to the right, then I decrease x by 1, then I move to up, then I move to down. So each time I move to the left, then x will increase by 1. Each time I move to the right, to the other direction, x will be decreased. And this is for the other direction. So this is the random walk function, and much simpler coding scheme or coding function, and the implementation. Now let us return back to the question. I want to return the function as it, because I want to use it now. Okay, so okay. The question is, what is the longest random walk you can take? Okay, so for example, you say, if you noticed in the previous execution, we have 30 trials, meaning that what is a trial that has the longest random walk? For example, if we go to the top here and we go down, we will end up 4 blocks from this O, either to this here, either to this, or to this, or to this. Okay, so we will end up, we will go from home, or from origin, and we move here and move down and move up, and we will end up at any trial 4 blocks at home. Suppose that we want to repeat the experiments 10,000 times. Okay, suppose that I will walk, for example, suppose that we will walk 30 steps, 1, 2, 3, 4 till 30, okay? And when returning, okay, suppose 30 will end here, I have to end it to count 4 steps to home. Suppose that these 30 steps will be repeated 10,000 times, okay? So let us simplify this because of the computational resource. Suppose that I will have similar trial, but I will have here 30 trials, and I can take, for example, 1,000, okay, 1,000 steps, any random 1,000 steps or 10,000 steps, okay, from here to here to here. Just I want to return back to be 4 steps, okay. Now let us see how can we code this. So I need the random walk function certainly, because I want to recall the function to count the steps if it's go to left, right, or north or south. Okay, and I want to keep this. Okay, remember that we will estimate the longest random walk. Okay, we can, so that in average we will end 4 blocks or fewer at home. Okay, now let us consider, for example, number of walks. Okay, like this. The number of walks will equal 10,000. Okay, now I want to move, as what we said, I want to move 30 steps, okay, to the home. Okay, so for walk length, let us give it this name, in range. Remember that we cannot use the 0, but we will use 31. I will clarify that, because when we count a step, we count step 1, not step 0. Because we want to use averaging. I want to clarify this more later. So in this case, okay, I want to make 30 trials, 30 experiments, or 30 trials, or 30 times of recalling the function. Okay. So if I end up 4 blocks as a distance to the home, then I don't need to use the transportation. So we can say no transport, okay, equal 0. Just a variable that will be used as a counter. Okay, then we will change the value. You can see follow later. Okay, now for I in range. Okay, the walk length, again, we want to walk 10,000 steps, okay, and we want to repeat this walk 30 times. I started from 1 to 31, this means 30, okay, so I want to call the function, okay, based on that. So for I in the range of the walk length, okay, then I want to estimate x and y now. So x and y equal to the random walk, which is this function, okay, random walk, and I want to pass the number of steps, okay, the walk length. So suppose that I will move for one trial, okay, for only one time, but I want to move 10 steps, okay, 10,000 steps, okay, then I want to recall the function, okay, if I move one step, okay, then I need no transportation, because if I move one step to the left, to the right, to the top, to the down, then it's still less than 4. If so, I loop even through the number of walks. Okay, so I make for loop here to move. If I move 1 step, if I move 2 steps, if I move 3 steps, if I move 4 steps. So in these 4 steps in other direction, I need no transportation. Then I consider till like this is 10,000 minus 1 step. Okay, so I loop through this. Okay, so this 10,000 steps. Okay, I start from 0 until to the end of this one. Okay, which is 10,000. Okay, minus 1. Okay, then I will estimate x and y for 1, 2, 3, 4, 5, 6, or for the first step, the second step, till the step number 10,000. Okay, now I want to calculate the distance. So the distance, nothing but the absolute value of x plus the absolute value, okay, of y. So this is the total distance. Okay, now if this distance, okay, is lower than or equal for, okay, what does that mean? In the question that I have, I need to count at any random step from from the first step to the step number 10,000. Okay, we want to end up, okay, 4 steps or less at home. Okay, 4 steps at less. If I count 4 steps or less, then I don't need a transportation to go home. Then no transport variable will be increased by 1. So no transport, okay, plus equal 1. Okay. So when I move from step number 0 to step number 9,999, okay, think of this. In the first, if I move, for example, in the first step, okay, then I need no travel. Then this one will be increased by 1, which is this variable. So it will be increased for the whole 10,000, but from 0 to 3 or from 1 to 4. Okay. Now let us to consider the percentage. So because we want to estimate the average number of or the average value of the no transport to the whole number of work each time. So we will estimate now the average. For example, we have no transport. Let us to say percent, which will equal to float. Okay, and the float of no transport. I want to take the float value because it's percentage. So we want to divide this to this number of random work, okay, which is the last number to the number of walks, okay, and then we want to multiply this by 100, okay, and we want to so if I move for the first trial, for the first trial, I will move 10,000, okay. Then I will consider the no transport, okay, and in this no transport, I will estimate the percent, okay, by considering this no transport and dividing it by the number of work, which is 10,000, because we have 10,000 update to this no transport, either to update by 1 or no update, which is 0. Okay, so I want to print f. Let us to say the real, okay, or let us use radical real, and we will consider I a year, or not I, the work length, sorry, and we will use the work length or average. Let us to say the average percent for the probability, you can see, equal to the no transport percent. And when we call this function, we will find this as the, and here to me the result is a little bit strange, because the inner loop here is looping through this outer loop, and this is not correct. I want to loop through the 10,000, not through the work length. And when we run this code again, yeah, we will see here that If we go from this trial, okay, in this trial, okay, we repeat the experiment, okay, which take the walk length, okay. We consider this walk length, okay, for one, okay. So I consider, okay, 30 trial, okay, and in the first trial, okay, I consider here 30 trials as I have in general, and in this trial, okay, we will consider the random walk, okay, function to be applied 10,000 times, okay, 10,000 times in the first step of 1 to 30, which means that we will repeat the experiments 10,000 times when we use the walk length of 1, meaning that 10,000 times the step will be one step, and this will be 100%, okay. I need no transport. For example, I will go one step to east or to west or to north or to south. So if I go one to up or one to down 10,000 times, I will stay in this region, in this grid, one by one. Okay? So 100 steps, 100%, I need no transport. And if I choose in the trial 2, okay, I choose the random function. I recall this function and I pass the argument number 2 here. So I repeat this experiment 10,000 times, but based on the walk length of 2. Walk length of 2 is still less than 4. So 10,000 times I will update this node transport by 1, so it will be like 10,000 here, and this 10,000 will come here and divided by this number of walk, which means that the number of repetition of calling the function, it will be 100% like this, even till 4. So to conclude, just this is the function, okay, that is simulate the random walk. It will return to me x and y, and the value of x and y is increased or decreased based on the number of steps. If the steps like equal 1, it will increase only by 1. Then I decided to repeat the experiments or the whole trial 30 times, okay? But and the first time I want to repeat the function calling 10,000 times, and from trial 1 to trial 29 or from trial 1 to trial 30, I will have 30 experiments, different experiments. In the first experiments, I will consider repeating function calling 10,000 times, and in all other steps I will do the same. But what I will change the moving. For example, I will in the first trial I will move one step. Okay, here I will move one step and I pass this step to the random function calling. In the second step, so suppose I finished this 10,000 looping iteration, I update this distance, okay, and I update this node transport variable. So this node transport variable will be 10,000, okay, if I move in step 1, 2, 3, 4. So for 1 and 2 and 3 and 4, I will have here the node transport is 10,000, and it will be like 100%. I need no transport. Okay. Now, if I move in another like 6, 7, 8, 9, I repeat the experiment based on the random sampling. Okay, and each time I repeat the experiment till reaching the last trial, which is the trial number 30. Okay, and in this trial I consider moving 30 steps in any direction. Okay, and I will see where I will stop. Stop here, stop here, stop here, and based on the sampling. Okay, now At each iteration from 1 to 30, I go globally here and I consider the no transport, okay, variable divided by the number of work. The number of work is fixed, and the no transport for the first 4 trials equal the same number, 10,000, which will return to me 100%. There will be no transport if I end up 4 blocks to the home. Now, back to the question. The question, what is the longest random walk? What is the longest random walk or random trial? If it's 1, 2, 3, 4 till 30, what is the longest one that I will end 4 blocks, okay, or fewer? 4 blocks or fewer, and the longest, meaning that I have to look at the 50% and more. So if I find in the trial number X that is more than 50, okay, or 50 or plus, that means that there is 50% chance that I will take the public transport. So if I move down to the trial number 22, okay, I will find that this is the longest random walk that I can take after repeating this trial 10,000 times, and I end up with average of 4 steps at or less, and this is the average or the average in person for dividing the no transport variable, okay, we defined here, okay, to the number of walk. So you cannot find 50% or more if you go, for example, to trial 30, 28, 22, 27. So 22 is the trial that contains 50% and more, okay, as chance or the probability that I will end up 4 block and or less at home, and this is the longest trial, meaning that practically trial 22 means that I move it from this origin 22 steps, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and suppose I move up and I move down, then I reach here, okay, but because I repeat this movement 10,000 times, then I averaged each time. So suppose that in 50%, I think 50%, 50%, it seems that roughly 5,000 out of 10,000 sampling or repetition will be and for 4 blocks at home, and the other 5 samples will be more than or for the other 5,000 will be more than 4 blocks at home. And by this exercise, or by the random walk and Monte Carlo, by the way, this is called random walk, okay, and repeating any function calling, okay, based on number of iterations. So we repeat this function calling 10,000 times, okay. So we repeat it. We call the function 10,000 times, okay, and we change the parameter of the function itself 30 times. This strategy is called Monte Carlo estimation, in which we repeat the experiments, for example, for 10,000 times, okay, and we take the average of the experimentation, and in this case we consider the average which taken from the transport variable. You can repeat any function call in the if you have a random function in your code, and later you can consider the percentage of this random. You can take the percentage of any variable you introduce, as what I did for no transport for this no transport variable. Okay, and again, this is called random walk, and the way that I iterate over the steps, which I taken here 30 steps, okay, and then I have another inner loop that will call the function 30 times and update the function based on this iteration is called Monte Carlo estimation. And by this Monte Carlo and random walk, we finished our Python function in this form. In the next tutorial, we will highlight recursion, in which we can recall the function from within. Thank you.